intermediate value theorem. Suppose f is continuous on the closed interval AB, and L is the function value or the y value, which is a number between the function at A and function at B. Then there is at least one number C in the interval AB satisfying f at C equals L. By using the graph to explain this, x equals A, x equals B, the graph continuous. So we have a smooth curve that draw from point A to point B. The function at A, f at A, the function at B, fb. By this theorem, if f is continuous from point A to point B, and there is the value L that appears between f and fb, there is at least one number C. At least one number, it could be more than one C. That's between A and B, or the beginning of the graph and the ending of the graph. That gives you the value L, which is in between the two endpoint values. Okay, so by the use of the intermediate value theorem, number one, we're going to check whether the function is continuous on the closed interval or not, or on the closed interval AB or not. And number two is the value L. L is between FA and FB. And then by the intermediate value theorem, there is at least one value, at least one, that means it could be more, at least one value called C, such that f at C equals L. Okay, you see L is the value between the function at A and function at B, and the function is continuous. So therefore, by the intermediate value theorem, or something intermediate in between, will be the value C that give you the function value L that can be found in between point A and point B, function value. For example, we use the intermediate value theorem for continuous function to show, that means it's already true, to show the equation square root of x to the fourth plus 22 x to the third plus 13 equals 4 between x equals 0 and x equals 1. In this case, your a is 0, your b is 1. So what is the function value? The function is not given very obvious in the problem, but the problem gives you in the form of the equation instead. So we're gonna rewrite the function as the left-hand side, which is the square root of x to the fourth plus 22, x to the third plus 13. Okay, and we're gonna use the L. So let's see, the value 4 here appears at some point C between A and B. So we're gonna put question mark here. We're gonna use the intermediate value theorem to show that that is the value C. C is between 0 and 1. That give you the function value equals 4. Let's see how it works, or is that true, by using the intermediate value theorem. By using the intermediate value theorem, number one, the function has to be continuous on the closed interval 0, 1. The way to check, the first thing that you can do is to look for the domain. But this one, since you have the square root, which is the radical with the even index, you're gonna have to set up the condition as the radicand is greater than or equal to 0, and then solve for x, or look for the interval that's greater than 0, including 0. It's not very convenient for this problem. We just kind of make a guess, or as a possibility, like, because we don't look for the entire domain, we're gonna have to make sure the graph is continuous from x equals 0 to x equals 1. As you replace the value 0, we can get square, let's check it out. So f at 0 square root of 13 and f at 1, we can get square root of 1 plus 22 plus 13, which give us 23 plus 13, which is square root of 36 or 6, the value 6. We can find the value at a and function value at 1. Okay, and somewhere in between is it should be satisfy the expression here without giving you the result as negative inside, because the value gonna be between the 0 and 1, and all the terms they all are positive term. Okay, so we can say that f of x is continuous on 0 and 1. Check. And then number 2, we have to look for the value at point 0 and at point 1, since we already found it from the process of the step 1. F at 0 is square root 13, f at 1 is 6. And we're gonna see that is 4 is the value 4 here between lie between f at 0 and f at 1 or not. Well, f at 0 is square root 13, which is somewhere between square root 9, which is 3, and and the square root 16, which is 4. So gonna be about 3 point something, 3 point something. And 4 is greater than 3 point something. Actually, 4 is square root 16. But we can see it's very obvious, it's greater than square root 13. With this answer, the answer is, with this question, the answer is yes. 34 is between f at 0 and f at 1. And then with these two assumptions, number 1 and number 2, f continuous and 4 is between the function at two endpoints. We can answer the question by the intermediate value theorem. There is a value x equals c between 0 and 1, such that square root of x to the 4th plus 22 x to the 3rd plus 13 equals 4. And you can verify by using the graph. Let's use the graphing calculator to verify the solution, the value 4 between the function value at 0 and the function value at 1. First, type in the function square root x to the power 4 plus 22 times x to the power second, and then plus 13. And then the second function would be y equals 4. We are going to look for the intersection of these two graphs. Okay, that's the graph. And let's check the y min, y max, x min, x max. So the window is set up to be x min at 0, x max at 1, and use a scale like by 1/5 or about 0.2 for the increment. Y min negative 10, y max is 10. So we can adjust it a little bit to be y min at 0. Okay, let's see how it works. So as you see, the blue curve is the curve of the square root x squared, x to the 4th plus 22, x to the 3rd plus 13. The red line is the line y equals 4. These two graphs intersect at is about like 0.4 some or close to 0.4. Okay, for the use of the intermediate value theorem, the theorem does not tell you what would be that number, but it will guarantee you that there will be at least one value that make it satisfy the condition. Or in this case, it will guarantee you that there will be a solution that will give that relationship of the square root equals 4. And you can trace to see the value, to approximate the value. So the value is somewhere between 0.3, the very close to 0.4, between 0.4.